Okay, welcome back everyone to Every Element Ever. Today we're talking about lithium. A really cool, a really sweet element. It's probably one of my favorite elements just because of its really cool name. It has this, I don't know, it's just a sweet name. Also it's like really silvery and white, and it's this really cool metal. It's probably the coolest metal in the whole periodic table in all our elements here. And you can see if you look on your periodic table, it'll look something like this. It'll be Li. It'll be on the far left of the periodic table, my left, your right. And it has number 3 here, the atomic number. So it's got 3 protons in its nucleus. Pretty cool. And it is in group 1 on the periodic table. It's all the way on the left side. So being on the left side, it means it is an alkali metal. Hydrogen is on top of it, but we don't care about hydrogen. You can just chuck that out the bin, whatever. Hydrogen's a gas, not a metal. Lithium's a really cool metal. And it is the first of the alkali metals. So pretty cool. I always like lithium. I don't know why. It's just like it's a cool sounding element, and it's really important in batteries. Not these kind of batteries, but other kinds of batteries, which we'll talk about shortly. But before we get to that, really cool factoid about lithium. Probably the coolest thing about it, and one of the really interesting fun facts on it here. It is the least dense metal in the history of everything forever, in all of the elements, all of the periodic table, the least dense metal. So pretty cool. I also like to add it is the lightest metal. So if you need like a super lightweight metal, if you need to like, I don't know, if you want to bend it and stuff like that, because lithium here is very pliable. If you want to impress your friends, you can grab a hunk of lithium and be like, oh, I can bend this metal, I'm super strong or something. And really it's just because it's lithium, and it's like, it ain't no steel or anything. That's for sure. It ain't like the other metals. So, the name here, the name for lithium, I had to think about this. I was like, where does a name like that come from? Where does this name come from? It actually comes from the Greek lithos. Lithos meaning rock or stone or a gray-like thing. So basically just think of like a big rock or a boulder or like some kind of stones and stuff like that. That's what lithos means. Think lithic. If you ever heard the term lithic, that means kind of like stones or rocks, studying those kinds of things. So that's where lithos comes from. Lithium, lithos, makes sense. And also the dude who discovered it, his name was Johann Ardenworf or something like that. He sounds like a character from World of Warcraft or whatever. But he was a chemist, and he discovered it in the 1800s. He discovered lithium, and he named it after the Greek word lithos, just because he did notice it was very stone-like. Even though it's actually not that dense, like technically you could probably come up with a better name for it, but that's what we came up with, and it's a very cool name, so I like it. And so did that chemist dude as well. So anyway. Moving on to its base form, it's playing the base form. So its base form here, this is what it looks like. So as we talked about, there's 3 protons in the nucleus, so this is its base form. Protons make the element what it is. But just know that its base form is mostly with 4 neutrons rather than 3, but these are the 2 most common ways you'll find it in nature, not including the isotopes. We'll worry about that another time, don't worry about that. But its most base form has 3 neutrons, mostly 4 neutrons though, so kind of cool. And here you can see its configuration of electrons. This is what's interesting about the alkali metals. So on our far left here, the first alkali metal being lithium, on the far left, all alkali metals have this configuration with 1 electron in their outer ring, in their outer shell, the blue tortoise shell that we talked about. So this outer ring here, lithium only has 1 little lonely electron. And because of that, that little lonely electron that hangs out, it wants to move away from its nucleus. It doesn't want to hang out with the protons and neutrons and say, leave me alone, get out of here, I need to get out of here. I don't like hanging out with you guys. And this means that lithium is very lightweight, not very dense. It has a hard time holding on to this electron, as do all the alkali metals. That's the feature of the alkali metals. They want to give up their electron. Basically, if they were a kid at lunch and he had a ham sandwich, he'd be giving up his ham sandwich to all the kiddos. He'd be like, oh, a ham sandwich? I don't want a ham sandwich. Here, you take it. Oh, you take this food. I don't want my Doritos. You take it. I don't want my Fritos. You take it. So they're always giving up their lunch. They're always giving up their electron. Which, when you give up an electron, it is kind of like giving up food because it creates a lot of energy. So it's like you're just giving up energy. So you're just, here, you take this thing. You take this thing. In the case of an electron here, think of electricity. So there's always a magnetic field, but lithium in particular, because it is so lightweight, it's actually the easiest to use for this purpose. And because of that, because of this feature of lithium, this amazing, cool feature of lithium, it is super duper reactive. Look at that. It's like a giant volcano. Not really, but you get the drift. But yeah, so it's super reactive, so it's always wanted to pump out that electron. The electron is very loosely bound, and it wants to jump, it wants to go, it wants to move. So super reactive. In fact, there's actually a cool video that I'll show you guys. Lithium even reacts with water. With plain old H2O, lithium is super, super reactive. It always wants to give up everything very easily. It's like, no, get away, get away. And even when in water, it's just chilling in water, and all of a sudden it just like bubbles up and it evaporates and it just like disintegrates, and you actually might see some flames as well. Yeah, I'm causing all this chaos. Here you go. And since it's reactive, I like to think of lithium, this is a fun way to think about it, it's super sensitive. It's super duper sensitive, which is perfectly alright. We need sensitive people in nature. And so if lithium were a person to be super sensitive, he'd be like upset about lots of stuff, and that's okay. You need the reactive, sensitive people in life, in the elements, because without lithium, we would not get a lot of energy. And so this sensitivity, this high reactivity is very powerful and very potent, very extraordinary. And without this ability of lithium to give up its electron, to release all that power and that electricity, guess what? We would not have the technological revolution that we currently have with lithium, with battery power. So, this is probably the coolest thing about lithium. Because of all these factoids of lithium as an alkali metal, that it gives up its electrons so easily, and it's so lightweight, and that it's so abundant as well. That's the other big factor, that lithium is found everywhere in mines, and rocks, and quarries, and you can actually extract it from seawater as well, which is crazy. But the lithium being so abundant here on Earth in rocks and minerals and stuff, that you can extract it, you can gather it and pump it in a battery, and specifically in these kinds of batteries, smartphones here, you got your iPhone, you got your Galaxy, you got your whatever, or in your digital camera, or especially in laptops. And I like to think of lithium being pumped into car batteries, so especially like Tesla batteries, Chevy Bolts, Nissan Leafs, all these cool new fancy lithium-ion batteries are in cars. Lithium allows that to happen, and it's a clean fuel source. Because all that's happening here is you're basically just taking lithium, like atoms of lithium, and you're just like, okay, now just, they want to give up their electrons very naturally already, and you just create the features in a battery to do that. And lithium does it very naturally. It's always giving up its electrons. And as long as you can catch it and maintain lithium in a nice, safe environment, it is very powerful and creates tons of electricity. Pure clean energy right here. It's just electricity going around. And it's an amazing feature of lithium that it just does that. And so because of that, we now have a clean fuel source instead of carbon, instead of fossil fuels. Lithium is a clean energy here. Electricity, it's just electrons jumping back and forth. And so there's no real, as far as we know yet, there's no real damage to the environment that is causing that. Electricity is a very natural thing because of these electrons jumping around. So thank you, lithium, for enabling this new technological revolution with our battery system. Pretty amazing stuff. One other weirdo thing about lithium is it does help with mood swings. People with mental health disorders, it actually is helpful with that as well. I haven't looked up all the crispy details on the science on that, but that's just a weird feature of lithium, that it's just, nature's very interesting, that the fact that lithium can be used as this atom in the battery revolution that we currently have with cars, and our whole technology has really benefited from the mining of lithium. At the same time, lithium also helps with your brain as well. It can help with like certain mental disorders, so that's pretty cool as well, that lithium has all these weird features, that some of the elements have all these multiple various features of them, and lithium definitely has that as well, another application for lithium. So there you go with lithium. That's all I got today for you guys on the channel. Our lovely, mysterious, cool sounding lithium. It is the coolest, lightest metal of all time. Hope you guys enjoyed learning something today, and check out more videos in the future. I will see you next time.